In this segment of the video, we're going to be looking at what reference angles are and how we're going to use them. Just as a starter, back when we were in geometry and we dealt with trigonometry, we were always in a little right triangle. So if we had some random angle, and we usually use Greek letters for angles in trigonometry, so I'm going to call that theta. If we were in a triangle like that, our theta was always acute because it had to fit in a right triangle. But now we're dealing with angles, and this will come in here, the values of the trigonometric functions of angles greater than 90 or less than 0 if we had a negative angle, then we still need to be able to work with them so they can be determined from their values at the corresponding acute angles called reference angles. So what we need to do is we need to come up with a way to take angles that don't fit into a little acute angle of a right triangle and still be able to do trigonometry with them. All right. So here it says, let theta be an angle in standard position. That's sort of our go-to. We like all of our angles in standard position now. Then its reference angle is the acute angle, because we want it to fit in a triangle. And now we can't call this angle theta necessarily, but it relates to theta, so we call it theta prime, which is a theta symbol with a little mark next to it, like an apostrophe, to indicate it's a relative of theta, but not theta itself. And it is formed by the terminal side and the x-axis. All right, so let's look at what would happen. Let's start back with the triangle we had above for just 1 second. If I had this triangle and I threw it into a coordinate system where my terminal side was up here, then theta would be its own reference angle because it is the angle in standard position, it's acute, and it's formed between the terminal side and the x-axis. So theta can be its own reference angle. But what if it doesn't land in the first quadrant? Here's an example where we land in quadrant 2. For any angle that lands in quadrant 2, and this is the example they've given, is this theta right here, our reference angle needs to be acute. So it needs to be a small angle. An acute angle is between 0 and 90, or so it has to be positive as well. So I'm dealing with this angle is between the terminal side and the x-axis, and I need to put my little arrow on the end to show that I'm turning in the positive direction. So that's my reference angle, which I call theta prime. Now, if I want to figure out how much theta prime equals, then I can use these two methods down here. Let's just give an example. If my theta up here were 140 degrees, then how much would be left for this reference angle over here? Well, it's the difference between 180 and theta. So I would say 180 minus 140 is 40 degrees, and 40 degrees is the amount that I have left to travel to get to the x-axis there. What if I were in radians instead? If I were in radians, instead of 180, this line would be at pi. That's the value of going all the way from the x-axis in the positive direction to the x-axis in the negative direction. So if I'm trying to figure out how big to make this portion right here, instead of doing 180 minus theta, I would do pi minus theta instead. All right, what happens if my angle lands in quadrant 3? So I have an angle in standard position. I'm spinning around. My reference angle needs to be between the terminal side, so this has to be one side of my angle, and between the x-axis. In order to keep this an acute angle, I need to choose the negative x-axis, and this is the space involved with my angle. In order to keep it positive and acute, I need to turn counterclockwise there. So in this case, if I were dealing with radians, my reference angle would be whatever theta was, which would be this big red arc right here. Take away pi would leave me with only the little portion that goes over. So theta prime, the reference angle, is theta minus pi. If we were in degrees, instead of being theta minus pi, we would be theta minus 180 degrees because pi and 180 are at the same place. All right, how about if we're over here in quadrant 4? If our terminal side lands in quadrant 4, our reference angle needs to be between the terminal side and the x-axis. I wouldn't want to choose this negative x-axis over here because that would give me an obtuse angle. So instead, I need to go back and I need to choose the positive x-axis so that I can have an acute angle in here. I still have to turn in the positive direction, and my theta prime would be this little angle right in here. Okay, so now I'm not measuring from pi or 180. Instead, I'm measuring from this distance, and all the way around the whole circle would have been 2 pi or 360 degrees. So how much am I missing in this little green arc right here? I'm missing 2 pi minus theta, or 360 degrees minus theta would tell me how big that little piece is. If you wanted to put all of your reference angles in one picture, which I sometimes like to do, if you're in the first quadrant, your reference angle's there. If you have a terminal angle in the second quadrant, your reference angle is here. If you end in the third quadrant, your reference angle's there. If you end in the fourth quadrant, your reference angle's there. And I call this a little bow tie. One of the mistakes you guys make in this class is you try to make reference angles in here with the y-axis. That will never happen. We can't have a reference angle with the y-axis. It always connects between the terminal side and the x-axis. It has to be acute, which also means the reference angle has to be positive. Okay, so we've got all these definitions right here, and we can look at that, but let's look into a practical situation with some of the examples down here below. So I'll scroll down here a little bit. All right, it asks you for each one to draw each angle in standard position and then determine the reference angle if it's not a quadrantal angle, because if we land on an axis, we can't be acute, right? All right, so let's start with 405. So I've got to draw 405 in standard position. Drawing in standard position means my initial side is on the positive x-axis. It means that I'm turning in a counterclockwise direction. If I kept turning all the way around to the start, I would have been at 360 degrees. But I need to go all the way to 405. And 405 is 45 degrees more than 360. So if I'm going to keep going, I need to go an additional 45 degrees. So the rest of my sentence up here says the terminal side makes one whole revolution counterclockwise plus 45 degrees more. So if I'm drawing my angle, this red thing is my angle theta, which is 405 degrees. And then to draw my reference angle is just this little bit right here, and theta prime would be 45 degrees for the reference, because that is the positive acute angle between the terminal side and the x-axis. Okay, let's try the next one. In this one, and I don't have to call it theta, I could make up another letter. I'm going to call this one beta. That's just a Greek capital letter B. Now my beta is negative 65 degrees. So because negative 65 is negative, the terminal side is going to be clockwise from the positive x-axis. So in standard position, I'm starting on the positive x-axis, and then I'm turning the wrong direction for an angle. I'm turning clockwise, and I'm just going to eyeball 65 degrees. Beta is negative 65 degrees. When I'm making my angles, I should really make sure definitively that they land in the correct quadrant. And this needs to have its terminal side down there in quadrant 4. And then I should try to make it a little bigger than 45 degrees, so a little more than halfway. I probably could have stood to make this swing a little more down, but that's okay, as long as you get it in the ballpark right spot. More importantly is the reference angle. Now the reference angle has to be the positive acute angle. A reference angle would never be negative. So beta prime, the reference angle, is that little green part I just drew, which would now be positive 65 degrees. All right, In C, I have my initial side on the positive x-axis. I'm going to go 150 degrees. I know 180 degrees would be all the way over to here, so I'm going to be just a bit short. I'm going to show that I'm turning in a counterclockwise direction. So that's 150 degrees. I make sure I put my little arrow only on the end to show which direction it's spinning. My reference angle is here between the terminal side and the x-axis. It has to be positive. So I'm just going to call this R since my original angle had no letter name to it. And my reference angle is how much further I have to go from 150 to get to the axis, which would be 30 degrees. All right, in D, we have a radian now. We have pi over 3. Well, let's remember just real quick, if this started out at 0, pi was halfway around because 2 pi was all the way around. That means that the positive y-axis is up here at half a pi. If I'm going to draw a third of a pi, I should realize that that's smaller than a half a pi. And it's going to go right about there. So in standard position, I have my positive side, or my initial side on the positive x-axis, my vertex at the origin. I'm spinning. I'm going to label this angle pi over 3 and show my arrow to tell I'm spinning counterclockwise. Now my reference angle for this one, pi over 3 is already a positive acute axis, so this is its own reference angle, and the reference angle is also pi over 3. All right, E is 5 pi over 6. Well, how much is this? Is this more than a half a pi or less than a half a pi? Where's it going to land? Well, if this is pi, in terms of sixths, how many sixths is 1 pi? Well, 1 pi would be 6 sixths. So 5 sixths is going to be close to a whole pi. I'll start my positive x-axis for my initial side. I will turn counterclockwise, and this is 5 pi over 6. I can also think of it, if I were to divide this into 6 pieces, because that's a pi, then 5 of those 6 pieces would put me there. My reference angle is what I have left. If I've gone 5 sixths of a pi, I need to do a remaining 1/6 of a pi to get up to 6 sixths of a pi. Be sure again that you have your angle turning in the positive direction, and it's the acute angle between the terminal side and the x-axis. Oh, I just realized down here it's asking me to write down the reference angle, and I haven't been writing them in the right spot. So this was pi over 3, and this one over here was 30 degrees. I was just putting them in the picture. Sorry, should have looked at the bottom first. Okay, I have a few more down here on the bottom of the page. In F, I'm dealing with 3 pi. So if I start out at the positive x-axis, remember turning all the way around the unit circle would have been 2 pi. Well, I need to go more than that. I need to go another whole pi. So another pi would put me over here, landing on the negative x-axis. So I've spun all the way around, and I can label that 3 pi. Now, this is a quadrantal angle because it lands on an axis, so there isn't a reference angle for that one. Okay, how about 4 pi over 3? Well, in terms of thirds, what would pi equal? Pi would equal 3/3. So if I need an angle 4/3, then I should realize that 4 pi over 3 is going to be down here in the third quadrant. Okay, but wait a minute, because I just randomly stopped it in the third quadrant. Let's think about how far it should actually go. Well, if I'm dealing with thirds of a pi, here's a pi as a half a circle. A third of a pi would be each one of these pieces. So let me go down to the bottom part of the circle. If I need to go 4/3, that's 1, 2, 3, 4/3. And this is actually more in that direction. So let me make my arc a little longer here. I've gone 1/3 beyond my pi. So my reference angle is pi over 3. On the last one, I'm going negative pi over 2. So in standard position, I'm starting on the positive x-axis. I'd have to turn negative, means I'm turning clockwise. And again, if this was a pi, a half a pi is right on the quadrant. I have no reference angle because I'm a right angle, a quadrantal angle. So you should be comfortable with drawing angles, reference angles, making sure you put your little arc showing which way you're spinning. And you also really need to be comfortable just adding and subtracting some basic fractions and being able to tell whether a fraction is greater than pi or greater than pi over 2 and those sorts of things. So come into class if you have any questions and let us know.